Hello and welcome to the section 3.4 lecture today for Algebra 1 Part 2. Today we're going to take a look at perimeter and area of circles, arcs, and sectors. So now I hope we don't need a definition of a circle. I'm going to go ahead and assume that we're good there. But let's look at a couple other definitions. So an arc of a circle is we're going to say that it's a portion of the exterior of a circle. Or maybe you might call it the boundary, a portion of the boundary of a circle. So if I just I'm going to use kind of the same picture for both of these, just to get a little bit of an idea. Now, I wish I had the center, but I'm just going to have to guess at where the center is. So let's go from there, and let's say that piece right there. So based on some angle in here, we've highlighted a piece of the boundary of the circle. And let's just use a different color here. So saying this green portion, this would be an arc. Not the entire circle, just that little bit, from this endpoint to this endpoint would be an arc. Now, a sector of a circle is a portion of a circle's area. Okay. Now, there's a lot more technicalities in there that it has to be. It has to go from the center along a radius, and bounded by an arc. But this portion in here would be a sector. Okay. Now, I've been tiptoeing around a couple words so far, and I really wanted to keep doing it, but at some point it's just got to come out there. What do we call the perimeter of a circle? It is just finding perimeter. We've dealt with perimeter so far in other sections, and now we're just talking about circles, but we have a special name for it. Okay, perimeter of a circle is called the circumference. Now, thankfully, we have that off of our chest now, because I dodge it for the whole side. For this whole page, I've dodged it the whole time. The perimeter and area of circles should not be new to you, but I do want to think about their formulas. So again, this is circumference. Again, I was trying to dodge it so that I didn't give the answer away. But what is the area formula for a circle? So some important pieces of a circle that we've kind of already talked about. From the center to an edge would be a radius. And all the way across would be the diameter. And we said that the distance around was the circumference, C. And obviously the space that fits inside would be its area. But what is the area formula? See if you can remember it. It is pi r squared. For circumference, we typically come up with two of them. One of them because it's how pi is defined. One way that we think of it is pi times the diameter. Or if you don't know the diameter and you know the radius, well, it's always true in a circle that 2 times the radius is equal to the diameter. So we could always say 2 pi r. Okay. One way to keep those straight that we've talked about over and over again, radius is always a linear measurement, right? Because it's just if I straighten out all the sides of this shape, how long does that take? And so you can tell that it's a linear measurement because there's only one unit measurement that's involved in the calculation. Diameter is the only unit measurement, or radius is the only unit measurement. Area has always been a squared value for us, a unit squared value. And that's always come, we haven't really talked about it, but that's always come because, in any kind of quadrilateral, any kind of parallelogram or rectangle, the area is the base times the height. So you have one unit measurement and a second unit measurement. In area, we have the radius counted twice. Well, the radius is a unit measurement. That's why our answer will be squared. Obviously, pi is a constant. Pi is actually defined. Pi was actually found by people measuring the distance around a circle and the distance across a circle and dividing those two. That's how pi came to be. They found, oh, this is always the same number. Okay, every time I take a circumference and divide the diameter, it's always the same number. So that's where pi actually comes from. So in these ones here, I want to find circumference and area. For this one, I have the radius. So I'm going to use the radius formula for circumference. So we're going to say 2 pi times 4, which you'll see a lot in higher levels of math that they'll leave it as 8 pi. This tells us to use 3.14 for pi. And even most calculators now have a button for pi. Like mine's right here, but it told me to use 3.14. So I'm going to say 25. I think it was 25.12. Yeah. And those would be linear feet. So there's the circumference. For the area, we only have one formula, pi times 4 squared, which is 16 pi, which would be double its circumference. But we'll go ahead and calculate it out, and that is exactly what we get, 50.24. And that's going to be feet squared. For the next one, we'll do the same thing. 2 times pi times 6.8. 2 times pi times 6.8. We get 42.0. Let's go ahead and go with just 7. 42.7. It's pretty close. Kilometers for the area, taking pi and squaring the radius, 6.8 squared. So I want 6.8 times 6.8 times 3.14. And we get 145 point, let's say 2. Again, these two measurements should not be new. You've probably covered them before. Now, when you get to a problem that gives you the diameter, you have a couple options. Number one is use the diameter the diameter formula for circumference. Or you can just always cut your diameter in half and give yourself a radius. This first one, I'll just go ahead and use the diameter formula. Just pi times the diameter. So 20 pi. 3.14 times 20. 62.8. And those are yards. The problem is for area, I'm going to need the radius. So I got to cut the diameter in half. It's 10. So 10 squared is 100. So we get 3.14 times 100 is 314. Didn't even need a calculator. Okay, the other thing you can do is cut it in half ahead of time. I can take 9.2 and divide it by 2 to get 4.6. And sometimes that's a little bit easier. So we'll use the 2 times pi times 4.6. Let's go 28.9. And those are inches. And then for area, pi times 4.6 squared. Let's call it 66.4. And those are going to be squared inches. Okay? So again, those measurements should not be new. Doing those calculations should not be new. Let's move on to something that probably is. When we start looking at arc length, trying to think if I was, yeah, kind of. So for arc length, it talks about a portion of a circle circumference. I'm going to say relative. I don't know if I missed this or what it is. So relative to what we call a central angle. Theta. That's a Greek letter. Looks like a 0 with a line through it. Technically, it looks a little bit different, but that's how we quickly write it. And then a sector is a two-dimensional area within a circle defined by an arc and 2 radii. So let's talk about how to find arc length first. So arc length is all about taking the amount of the circumference that you want to deal with. Okay. The way we find that, the way we find our arc length is we denote it with the script L. And so we want to take the central angle, theta, over 360, because that is the portion of the circle that we're dealing with. It's kind of like finding a percentage of the circle. But instead of dividing by 100, we divide by 360. That'll tell us the amount of the circle that we want to deal with. And then it's just that times the circumference. Okay, so you could look at it as the arc length is equal to theta over 360 times 2 pi r, or times pi times the diameter, whichever way you want to do it. Okay. Most of the time I'll probably be given the radius, so I'm going to use that. So let's go ahead and give this a shot. It turns out that 270 degrees is like 3/4 of a circle, which would make sense because this would actually reduce to 3/4. And we're going to say times 2 times pi times 9. And again, that reduces to 3/4 times 2 pi times 9. And I'm just going to multiply everything and then divide it all by 4. 3 times 2 times 3.14 times 9 divided by 4. And we end up with 42.4. And again, that's, since it's a portion of the circumference, it is a linear distance. For this one, we have 30 degrees as a central angle. So we're going to have 30 over 360, which would reduce, but I'm not going to stress out about that too much. Times 2 times pi times 19. If you want to, you can just go 30 over 360. Okay, pretty small portion. Times 2 times pi times the radius. And call it 9.9. So you can see, once you get the formula, it's not too bad. Put it into the calculator. Make it do the work for you. 225 over 360 times 2 times pi times the radius. And we get 11.8. And those are centimeters. So not too bad. Moving on to find sector area, it's going to be the same idea. It's the portion of the circle times, or let's say that it's the area of the circle times the amount of the circle that we're dealing with. So for area of a sector, we're going to have that central angle divided by 360 times its area. Because we're only dealing with that much of the circle. So let's take a look at these two. Here we have 60 over 360. Which reduces, but it doesn't reduce to 1 over 300 like some people want it to. So be aware of that. 60 divided by 360 times 3.14 times 8 squared is 64. And so we get 33, call it 33.5. Since it is an area, it's a unit squared, so this is 33.5 miles squared. On the last one, the amount that I'm dealing with is 150 degrees of the circle. So we would say that the area is equal to 150 over 360. And sure, that would reduce, but I'm not going to stress about it too much. And we have a 12-foot radius. 150 over 360 times 3.14 times 12 squared is 144. So we get, I didn't think about it, 188.4. And that would be in square feet. Okay, so good deal today. Had a little bit of old stuff and some new stuff as well. But I hope that this is kind of an easier way to look at it. Okay, for sector area and arc length, we're just dealing with a fraction of a measurement that we've already found, whether it be area or circumference. Okay, make sure you put any questions you have on the left. Other than that, have a great day, and we'll see you in class.